In this exercise, we will find the critical value that is associated with a two-tailed test when testing a claim about a mean where sigma is unknown. In a sample of 106 body temperatures, it was found that they have a mean of 98.20 degrees Fahrenheit and a standard deviation of 0.62 degrees Fahrenheit. Use a 0.05 significance level to test the claim that the mean body temperature of the population is equal to 98.60 degrees Fahrenheit, as is commonly believed. We'll begin by finding our claim. Here, the claim states an equality equal to 98.60 degrees Fahrenheit. Thus, our claim is that mu equals 98.6. Our null is going to still be the equality case, here the claim. The alternative would be the opposite of the claim, here being the not equal to case. Since our alternative is not equal to, this means we are going to be using a two-tailed test in order to find the critical values for this particular exercise. Now, nowhere in the problem is sigma given, sigma being the standard deviation of the population. The standard deviation as given, 0.62 degrees Fahrenheit, is in fact the standard deviation that comes from our sample of 106 body temperatures. Thus, we must use the student t-distribution in order to get our critical values here. Now, since this is the not equal to case with the student t-distribution, I am going to be looking to divide up my area into two tails. So thus, I am going to have two different critical values that result here. When I look at my original alpha, it is 0.05. Alpha over 2 will be 0.025. Thus, the area in each one of these tails will be equivalent to 0.025. In order to find these particular critical values, we need to look at our degrees of freedom. Our degrees of freedom here would be an n-1 or 105. If you're using your chart, it is okay to use a degrees of freedom of 100, which is the closest value on the chart that we would see. If you're using your TI-8384 graphing calculator to find your critical values, please refer to our graphing calculator videos to help aid through this process. From this particular degrees of freedom and looking at an area in two tails total of 0.05 or an area in one tail of 0.025, we will get two different t-values. We will get t-values of 1.984 and a negative 1.984. Thus, we can see at the end that we have critical values from our student t-distribution of t being equal to plus or minus 1.984. Thus, we have found the critical values for this example that are associated with a two-tailed test when testing a claim about a mean where sigma is unknown.